Hello everyone, I am Deepak.R, studying in Sri Venkateswara College of Engineering. Today I am going to explain about the Warshall Algorithm. We use Warshall Algorithm to find the transitive closure of a directed graph. For example, I took this directed graph and today I am going to explain how to find the transitive closure of this directed graph. For this, we have to first find the adjacency matrix, that is R0. This is adjacency matrix. Now, in where there is a path, there we will write 1, and there is no path, we will write 0. There is a path from A to B, so it is 1. There is a path from B to D, so 1. And there is a path from D to C and D to A, D to A and D to C, and the remaining we write as 0. In next step, we are going to find out the R1. A, B, C, D, A, B, C, D. In R0, we mark the column which is from A and the column from A. In R1, we marked values as same 0, 1, 0, 0 and 0, 0, 1. And where there are 1, we write same as it is. D to C is 1 and B to D is 1. And remaining values we have to find. B to B. B to B. Since we are considering from the vertex A, so B have to visit first A and then have to visit the B. So B to A and A to B. B to A is 0 and A to B is 1. So 0 and 1, which is 0. 0. Next, B to C. Since we are considering from vertex A, it is from B to A and A to C. B to A is 0, A to C is 0. So 0 and 0 is equals to 0. It is 0. Next, since this third row is full zeros, we get this third row as 0. And D to B. D to B. D to A and A to B. D to A. D to A is 1 and A to B is also 1. So it is 1 and 1. So we write 1. This is 1. Next, D to D. D to A and A to D. D to A is 1, A to D is 0. So 1 and 0 we get 0. This is R1. Now we will mark second row, second column with respect to vertex B. Now we are going to find R2 with respect to R1, that is from with respect to vertex B. So since we mark second row and second column, we write it as same. So it is 1 0 0 1 and 0 0 1, and the ones which are there, that is D to A and D to C, we write as same 1 and 1, and remaining values we have to find, that is A to A. Since it is from vertex B, so A to B we have to visit B and then B to A, which is A to B. A to B is 1 and B to A is 0. So it is 1 and 0, 0. A to A is 0. Next, A to C. A to B and B to C. A to B is 1, B to C is 0, 1 and 0, it is 0. Next, A to D. A to D is A to B and B to D. A to B is 1, B to D is also 1. So 1 and 1 we get 1. A to D is 1. Next we have to find C to A. Since third row is full zeros, so we get zeros. Next we have only D to D. Since it is from vertex B, so D to B and B to D. D to B is 1. D to B is 1. B to D is also 1. So 1 and 1 we get 1. So it is 1. Next we are going to write R3, that is with respect to third column, third row with vertex C. Next A, B, C, D, A, B, C, D. Since we are writing third row and third column as same, 0, 0, 0, 1 and 0, 0, 0. And ones place as same. Since we are writing with respect to third column, as the third row elements are all zeros, we get the same matrix as R3. So 0, 0, 0, 1 and we write same matrix. And next we are going to mark the last row and last column, that is with respect to vertex D, we are writing R4. A, B, C, D, A, B, C, D. We write last row and last column as same, and where there is 1 we write as same, and we have to find the remaining values. That is, we are going to find A to A from with respect to D, so A to A, that is A to D and D to A. Since A to D is 1, A to D is 1 and D to A is also 1, we get 1 and 1 is equals to 1. Next, so it is 1. Next, A to C. A to C. In A to C, we write A to D and D to C. Since A to D is 1 and D to C is also 1, we write 1 and 1, that is 1. So it is 1. Next, B to A. B to A. B to D and D to A. B to D is 1 and D to A is also 1. So 1 and 1 we get 1. B to A is 1. B to B. B to B with respect to D, B to D and D to B. That is B to D is 1. D to B is 1. So 1 and 1 we get 1. 1. Next, B to C. In B to C we find B to D and D to C. B to D is 1, D to C is also 1, so we get 1 and 1 is equals to 1. Next, this is 1. Since third row is full of zeros, we get as it is. So we obtain R4. This is the transitive closure matrix. Therefore, transitive closure matrix is that is 1 1 1 1 1 1 1 1 0 0 0 and 1 1 1 1. This is the transitive closure of a directed graph. We found the transitive closure of a directed graph. Thank you for watching.